Okay, so hello guys. So today we are going to be I'm going to explain you rotate linked list. The question states that we are given a single linked list, and we are given an integer, let's say 2, and we want to rotate this linked list to the right by 2 positions, like let's by 2 rotations. Like let's say now it is 5, so at first rotation it will go to 5 1 2 3 4. At the second rotation it will go to 4 5 1 2 3 4. So as an integer is given, we are said to rotate the list by that amount of integer. So let's say it is given as k is equal to 4, so we are said to rotate this list by 4 rotations. Now this problem can be solved by giving some intuitive method. Like let's say if we want to rotate a particular list, so if the k is the same as the length of the list, then we are not allowed to whatever we do means we are just going to get the same result as the linked list. So let's say k is equal to 3, so after 3 rotation the input linked list and the output linked list will be same. So if the k is divisible by length of the linked list, then it doesn't matter how much we rotate, we are going to end up into the same position. So the number one thing we need to check is if k is divisible by the length of the linked list or not. Now let's start by the second thing, that is if k is not divisible by the length of the linked list. So let's say we are given this type of linked list 0 1 2, and second point is means it is pointing to null. After that what we will do is, let's say we cut this we cut this null pointer, means we don't point to null now, the tail of the list. Instead we point to the head of the list. Okay, so it's kind of like creating a cycle. So means what we are doing is we are pointing our tail to the head. Now whatever we do, we will be inside the cycle. That means this loop will never be if we try to go inside this loop, we will never be out of the loop anytime, because we are not pointing to null. So the first method is to create a cycle such that whenever we rotate, means we rotate, then we will get at a position where k will end its value, and we will point that particular node to the null. So let's visualize one more time. So let's say k is given as 4, so we will check if k percent the length of the list, is it divisible by means is it divisible by the length of the list. So here length is 3, so k now becomes 3 minus 1, means k percent length, that means 3 k is how much? K is 4. So if I say that 4 divided by 3, so it's not divisible by 3, so that means we are going to get another linked list. So now how much rotation we need to do? So the rotation means needed right now we need to do is the whatever k we have, we will subtract that from the length of the linked list. So if the length is 3, so we will say 3 minus k percent length. So now we need to do 2 rotations yet. So let's start with this. So first rotation, we will point to the tail of the linked list, that is 2. Then after that when we do the first rotation, we say that our tail now becomes equals to its next position. So the next position, the next pointer, the 2 which is pointing is to now 0, so our next pointer becomes 0. Then after that, or at the second, when k is equal to 2, we will say whatever the next pointer of 0 is there, we will point to that particular node. So next pointer of 0 is 1, so we will point to 1. Now as we can notice that k has ended its value, that means we are allowed to perform only 2 rotations. So k has now ended its value. So now what we will do is we will cut that node. We will cut that means the 1 and 2, means we will cut a connection between 1 and 2. So as we have reached our tail, because now our rotation has been over, so we have reached our tail, so we will cut the connection between our current tail and whatever next node we are having. So as we cut our as we cut the connection, we are now arrived at the new tail and new head positions. And now you might be wondering, what are those new tail and new head positions? So as we can see that when we cut the connection, we are pointing now our 1, that is our tail, to the null position. That means we have reached our tail, and our new head and new tail becomes like this. So as you can notice that our head is now the new connection, that is 2, and our tail becomes 1. So this is the format of the whole code. So let's just go one by one step. So let's start. Okay, so what's the base condition we need? We need that if our head is not present, that means there is no rotation. So we'll say just means return the head. That means whatever we rotate, we are not going to get another kind of list. Then next thing, we need the length of the list. As we checked here, we need the length of the list, so that we don't end up being like running the loop too many times. We just want whatever part remaining from the divisible after dividing the k from the length of the list. Okay, so let's define our length to be equals to 1, starting from 1. Then what else we need? We need the pointers. We need that our head should be pointed to first. Our head should be pointed to here, and our tail, our first tail should also be pointed to here. Now after that, when we calculate the length, we will traverse our tail part to the end of the loop. Okay, so let's just make one first and a last pointer, and we will first point to the head. Now we need to calculate the length of the list. Okay, length of the linked list. So how are we going to calculate that? We are just going to say that until our last dot next is not equals to null, until means while last dot next, that's also fine. So until there is some means connection from the current node to the next node, we will just iterate over the array, and we will change our value to the next pointer, and we will say length plus plus. That means we have a new length. After that, what we need? We need that we want to create a cycle. We want to say that our last node now will point to the head. That means we have created a cycle. Okay, so now what? After creating a cycle, what we want is we want to check if k is divisible or not by length of the list. Now if k is divisible by length of the list, that means whatever rotation we do, we are going to end up with the same linked list as an input. Okay, so let's just means check what's the value we have. Okay, so k% equals length. Okay, so it's the same as saying k is equals to k% length. Okay, now after that we are going to check if k exists. Okay, that means it's if our k is not equal to 0, we are going to perform some operations. And what are those operations? So so what we want is, now as we are pointing to the tail of the linked list, that is 2. Now during those operations we want to our tail should now rotate itself from 0 to 1 until our k is not equals to length minus k. So that means we want our for int I is equals to 0 till I less than length of the list minus k and I plus plus. We want our tail to be rotated until we end up until our loop ends. So our last is equal to last dot next. Now so as we can see, we are pointing our last to last dot next. That means we are just inside a cycle and we are just rotating the cycle until we reach a point where k becomes equal, where I does not satisfy the condition. So now we have reached a point where last is the tail, and the next connection we have is now head. So we need to cut our last and the head, and we want to point our last. That means we want to connect the last and the head, and we want to point our last to the null, so that when returning the answer, the answer should not be inside the loop only. That means the loop should end also. So that's why. But before losing the connection, we want our first, that is this point, to be pointed to this position. That means now this is our new head. Okay, as you can see, this is our new head. So we want our first to be equals to last dot next. And what's the last dot next? Last dot next here. Last dot next is now 2. So our first is pointing to 2. That means it is our new head. And our last dot next, now which was just a second. Okay, yeah. So which was pointing to 2, now it is pointing to, now it will be pointing to null, because we want to end our loop. So that after that we just will return the first, and that's it. Let's see if there is no error. It should work. Okay, and okay. So what's the error? List node last we have created no member named head. Okay, so why there is no member named head? Oh yeah, sorry for that. It's next, not head. There's no any other error. Okay, yeah. So should be error, still any error? Oh yeah, it's null. I always do this. Okay, now it is pointing to null. Please no syntax error. Okay, so list node, still an error. Wow. Okay, so last is pointing to last dot next. Okay, so list node, last is head, right? So length is 1. We are checking the last dot next, so last dot next, and then we sorry. So as we can see, our last dot next should be equals to head. Okay, so that's what the freaking mistake that I was doing. Okay, so okay, this test case is passed. Let's hope this is also passed, and we have passed. Alright, so this was the code for the linked list when we want to rotate the cycle and all. So if you like it, then share and subscribe, guys. Okay, cheers.